So today we're going to be doing a question on sequences and series that came up in 2017. And in this question it says the amount of a substance remaining in a solution reduces exponentially over time. An experiment measures the percentage of the substance remaining in the solution. The percentage is measured at the same time each day, and the data collected over the first 4 days are given in the table below. Based on the data, estimate which is the day on which the percentage of the substance would be less than 0.1%. So basically, we're given a table and it says on day 1, and then it gives the percentage of the substance that's left. So on day 1, we have 95%. On day 2, we have 42.75%. On day 3, we have 19.2375, and on day 4, we have 8.6569. Now, we're asked, how do we know this is a sequences and series question? Well, we can look at if it's increasing exponentially. So we can check if it's a geometric sequence by saying that if the ratio between two of each term is a constant. So by doing that, we'd put one ratio over another, so 42.75 over 95. So I'm going to plug that into my calculator. 42.75 divided by 95, and I get 9 over 20. So that's the ratio between the first two terms. Now I'm going to look at term 2 and term 3 and see what I get. So I'll get 19.2375 over 42.75. I'm going to plug that into my calculator over 42.75, and I get 9 over 20 again. So it seems that we have the same ratio. So then it's 19.2375 over 8.6569. Sorry, I did that the wrong. 8.6569 over 19.2375. And then I get, for the last one, I get 8.6569 over 19.2375. And it's just after coming out in decimal as 0.45, but 9 over 20 is equal to 0.45. So they're all 9 over 20 or 0.45. So the ratio, so if we multiply this by 0.45, we'll get this. If we multiply this by 0.45, we'll get this. Similarly, if we multiply this by 0.5, we will get answer number 4. So we're asked, so we're asked to know what day will the percent, which is this value, be equal to 0.01. So we're looking to get the term number at 0.01. So in order to get the term number, we have to use a form for geometry. So we're after confirming that it's geometric by saying that the ratio between each of the terms is a constant. So the ratio is equal to 9 over 20. That's our ratio. And our first term is 95. And we know that if we're dealing with geometric, from our log tables, the term, any term will be equal to a, which is the first term, by the ratio by n to the power of n minus 1. So that's the general term of any geometric sequence. So we're going to have to plug our values into this. So our first term is 95, so that's a, and our ratio is 9 over 20. And we're looking to find n. We don't know n, but our term is going to be less than 0.01. We're looking for what number of n will give a value of 0.01. So that's what we're trying to find. We're looking to figure out n that will satisfy this. So firstly, we're dealing here with indices. And when I have a number multiplied by a thing with a power, the easiest thing would be to divide both sides by 95, and then we'll get this base here by itself. So if you divide both sides by 95, then we get, this will cancel off, and we'll get, just stick that into my, so I'm getting 9 over 20 to the power of n minus 1 is less than or equal to 1 over 1500. So now what I need to, so I'm trying to get this power here. So a way I could do that is I could take the log of both sides. So if I take the log of both sides, so it'd be log 9 over 20 n minus 1 is equal to log of 1 over 9500. So after taking the log of both sides, and we know that in logs, if this number here is being multiplied by a power, we can also multiply the whole of the log by that. We can multiply, we can bring the n minus 1 here, so it's n minus 1 by log 9 over 20 is less than log of 1 over 9500. And now I'm actually going to go on to a new page, but I'm going to keep what I'm just after doing. So the last thing we had written on our page was n minus 1 log, so I'll just bring the page down here so you can see it. So that's the last thing we had written on our page. And now I want to get n minus 1 by itself. So if I divide this, but I'm multiplying by n minus 1 here by our log 9 over 20. So if I divide by log of 9 over 20 on the opposite side, so it'll be n minus 1 and then over log of 19500 over log of 9 over 20. And I'm just going to plug that in. So I'm just going to plug that into my calculator. So I get a log of 1 over 9500 over log of 9 over 20. So, and because I divided by log of 9 over 20, and that's a negative log, I'm going to have to change the sign. So it's n plus 1, n minus 1 is greater than 11.47. So now we're looking for to get n by itself. So you see log, if you plugged it into your calculator, 9 over 20 will get a negative value. And when we're dividing by a negative value, the inequality direction has to change. So it's n is greater. So we're bringing our 1. If we're just adding across, if we're just moving it from one side to the other, the inequality direction doesn't change. Only when we're multiplying or dividing by a negative quantity. So then it's going to be 11.47 plus 1. So n is going to be greater than 12.47. But we are asked what day, so n is the day, the term number, which for each term is a day. We are asked what day will the substance, the first day that it will be, as 0.01. So on the 12th day at at 12.47 through the day, nearly 12 and a half days, it will be 0.01. So it will be so it's going to be day 12 will be the first day that we'll have 0.01% left, and that is our answer. Thank you.